Everyone, welcome to today's video where we dive deep into Google Cloud Observability, Application Performance Management, APM, and cost optimization. These topics are crucial for anyone managing applications or workloads in the cloud. Whether you're a cloud architect, developer, or administrator, this video will give you the insights you need to optimize both performance and costs in Google Cloud. First up, let's talk about how to configure Google Cloud Services for observability. Observability is all about ensuring you can monitor and track the health and performance of your resources. Whether it's virtual machines, databases, or networking components, you want to set up monitoring systems that give you real-time insights. Let's start with cloud logging. Cloud logging is a fully managed, scalable log management service. It lets you store, search, analyze, monitor, and alert on log data and events from Google Cloud services, VMs, and even third-party services. It captures system and application logs, providing insights into what's happening in your infrastructure. Log collection gathers logs from Google Cloud services, applications, and third-party systems. Log search allows you to search through logs using structured queries. Log-based metrics convert log data into metrics that can trigger alerts or be tracked over time. Alerts and monitoring set up real-time alerts based on specific log patterns. Cloud monitoring tracks the performance of your cloud infrastructure and applications. It collects metrics like CPU usage, memory, and disk I/O, and provides real-time insights into the health of your resources. You can create dashboards to visualize these metrics, set up alerts, and monitor uptime. Metric collection automatically collects metrics from resources such as VMs, Kubernetes clusters, and databases. Dashboards, customizable dashboards to visualize key performance indicators, KPIs. Alerting, set up alerts based on predefined thresholds. Uptime checks, monitor service availability and receive alerts if downtime occurs. CloudTrace is a distributed tracing system that monitors the latency of requests as they pass through your application. It helps you pinpoint bottlenecks by visualizing how long each component of your application takes to process requests, which is especially useful in microservices-based architectures. Latency analysis measures how long individual requests take to process. Bottleneck identification detects performance bottlenecks, highlighting the slowest parts of the system. Service dependency mapping shows how services interact. Let's continue with configuring Google Cloud Services for observability. Ops Agent for Compute Engine. One of the first steps in setting up observability is installing and managing the Ops Agent to collect logs for Compute Engine. The Ops Agent is designed for collecting both system and application logs and metrics, simplifying the process of monitoring Google Cloud Services. Key features: log collection and metrics. The Ops Agent automatically collects logs and metrics from Compute Engine instances. Easy integration. It integrates seamlessly with cloud logging and monitoring, providing insights from logs and metrics in one platform. Managed service for Prometheus. For more advanced monitoring, you can use Google Cloud Managed Service for Prometheus. This service helps monitor your Kubernetes workloads, providing rich metrics from containerized environments. When to use Managed Service for Prometheus when working with Kubernetes clusters or when detailed metrics on containerized environments are needed. Analyzing VPC Flow Logs and Firewall Rules Logs. Another critical part of observability is monitoring network traffic. VPC Flow Logs and Firewall Rules Logs provide insights into network traffic, helping you identify performance issues or security breaches. When to use VPC Flow Logs when monitoring network traffic in your virtual networks. Now let's dive into Application Performance Management, APM. Google Cloud provides tools like error reporting, Cloud Trace, and Cloud Profiler to help you identify and fix performance issues. Error reporting aggregates and analyzes your application's errors, automatically identifying and grouping them. It alerts you whenever new ungrouped errors occur. When to use, detect and track errors in real time. Prioritize issues based on error severity and frequency. Cloud Profiler, what it does. Cloud Profiler continuously profiles your production applications, providing insights into how they use CPU and memory, which helps you optimize resource consumption. When to use. When your application is running slowly due to high resource usage, to fine-tune performance after functional issues are resolved. Optimizing costs in Google Cloud. Running workloads in the cloud comes with costs, and it's essential to keep them under control. Here's how to optimize your costs in Google Cloud's Operations Suite. Cloud logging is priced based on log ingestion volume, so monitor your usage carefully after the free 50 GB per month. Similarly, cloud monitoring and cloud trace costs depend on the volume of metrics and trace spans ingested. Best practices for managing costs. Here are a few best practices for managing costs. Exclude unnecessary logs. Exclude high-volume logs, e.g. HTTP 200 OK responses. Export logs to cheaper storage. Store logs in cloud storage or BigQuery for cost savings. Optimize custom metrics usage. Limit custom metric labels to reduce ingestion costs. Let's look into an example. You're managing a high-traffic e-commerce web application hosted on Google Cloud. Recently, your customers have been complaining about slow page load times and intermittent service outages. Additionally, there have been security concerns regarding unauthorized access attempts. Your application architecture involves compute engine instances, Kubernetes clusters for microservices, and a VPC network. Your task is to identify the source of the performance issues and latency, investigate security breaches, optimize resources to reduce costs, ensure network health and that firewall rules are functioning properly. Problem detected. You start by using cloud monitoring to get a high-level overview of your system's performance. You notice that CPU and memory usage on several compute engine instances and Kubernetes clusters are unusually high, with intermittent spikes in resource consumption. An alert shows that the CPU usage has been consistently over 90% for the past few hours, and response times for the web application are degrading. To dig deeper into the performance of your compute engine instances, you use the Ops agent to collect system logs and metrics from your VMs. The logs reveal frequent memory spikes and application crashes, which are not apparent from high-level monitoring metrics. Since your application is partially deployed in Google Kubernetes Engine, GKE, you use the managed service for Prometheus to monitor your Kubernetes workloads. Prometheus provides granular metrics, showing that a specific microservice in one of your containers is consuming more memory than expected. This microservice is responsible for handling real-time product recommendations. To troubleshoot the slow page load times, you use Cloud Trace to track the latency of requests as they travel through your microservices. The trace data shows that requests are taking a long time to complete, particularly during the database query step for retrieving customer order information. While analyzing logs using cloud logging, you detect multiple unauthorized login attempts on your web server, originating from suspicious IP addresses. The logs also show several 500 internal server errors, which correspond to the application downtime noticed earlier. To ensure that the network is performing correctly and that there is no unusual traffic behavior, you analyze VPC Flow Logs. These logs reveal that there is unusual inbound traffic from certain IP addresses, potentially contributing to the security concerns and degraded network performance. Finally, you check the Firewall Rules Logs to ensure that firewall rules are working as intended. You find that some firewall rules are allowing traffic that should have been denied, which might be contributing to the security issues. To wrap it all up, observability in Google Cloud ensures that your applications and systems are healthy, performing efficiently, and cost-effective. By leveraging error reporting, CloudTrace, and Cloud Profiler, you can investigate performance issues quickly and optimize the use of your cloud resources. And don't forget, managing your costs with practices like log exclusions and using the pricing calculator will help keep your cloud budget under control. Thanks for watching. I hope you found this breakdown of Google Cloud Observability and cost optimization useful. If you enjoyed this video, make sure to give it a thumbs up, subscribe for more cloud content, and leave any questions in the comments below. See you in the next one.